Hello, this is Mr. Manley. This video is an introduction to imaginary numbers. I'm not going to get into the theory or the why of it in this video. I just want to show, we're just going to look at how to work with them. How do we work with imaginary numbers and leave the question about what they are and what they mean outside of it. So here I have the square root of negative 48. And we're going to use this property of logarithms, property of radicals, which says the square root of AB is equal to the square root of A times the square root of B. And you should have used this many, many times before. So the way that I'm going to use that in this case with the square root of negative 48 is I'm going to say that that's equal to the square root of negative 1 times the square root of 48. And then with the square root of negative 1, this is what we are going to call I. We could just leave it as the square root of negative 1, but it's more convenient and it introduces us to this other number, this so-called imaginary number, I. So whenever I have the square root of negative 1, I'm going to rewrite that as I. And then let's take this square root of 48 here and let's do some property of logarithms on that. Like I could say that that's the square root of 16 times the square root of 4. And then the square root of 16, of course, is 4i rad 3. And that is a simplification of the square root of negative 48 to 4i times the square root of 3. So now, anytime that we see a negative radical, we could rewrite it without the negative with an I. So here I have a square root of negative 24, which I can write as I times the square root of 24. And then the square root of negative 2 there is I times the square root of 2. So I've got an I over I, and certainly, like any other number, if I have that number over itself, it simplifies to 1. I over I is equal to 1. Now this square root of 24, you might get involved in the business of trying to simplify this, might be thinking about rationalizing the denominator, but we want to be flexible and keep our eyes out for convenient equivalent expressions. So look at, if I write the square root of 24 as square root of 2 times the square root of 12, now I've got a pair here that matches. Square root of 2 over square root of 2. And then the square root of 12 is rad 4 times 3. And we get 2 rad 3. Okay, and here's some more. Square root of negative 15. Let's see if we can do a little bit more here. We're kind of looking ahead, right? We see where this is going. The square root of the negative, it gives me I. The square root of 15, I'll go square root of 5 times the square root of 3. The square root of negative 3 is going to give me an I and a rad 3. Now we're going to match some things up here, or combine some factors here. So I've got an I and an I, that's I squared. I've got a square root of 3 square root of 3, that's 3. And then I'm left with the square root of 5. All right, now if I is equal to the square root of negative 1, and I have I squared, that would mean that I squared is I times I, which is the square root of negative 1 times the square root of negative 1. And when I do the square root of anything times the square root of that same thing, what do I get? I get that same thing. Like if I have the square root of some strange symbol and the square root of the same strange symbol, the square root of that times the square root of that is that symbol. This is how radicals work, right? So I squared is -1. So I've got -3 rad 5 after all said and done. And that is an introduction to working with imaginary numbers.